So today we learn features of C#.NET. Now, in these features of C#.NET, one is platform independent. Okay. So connecting with this platform independent, let me make you clear of what all happens during the program or application development using what? .NET. So we'll come up with one simple architecture so that you could justify what and how these things works for platform independent. Okay. Right. So a lot of things would be covered through this, first feature about platform independent. Right. Say, for example, this is your .NET application. Okay. Developed in any of these two subjects. .NET application. Developed in either C#.NET or VB.NET. These two are our languages. Okay, let me mention here. This is .NET application. And where it is developed, either it is in C#.NET or it is in VB.NET. And what is this code called? Source code. This program, whichever you write, you refer it as source code. Okay. And once you develop this application, we hand over this application to respective language compiler. It means if your application is developed in C#.NET, you hand over it to C# compiler. If it is developed in VB.NET, you hand over it to VB compiler. If program is developed in C language, you hand over it to C compiler. Means which language, in which language you are writing your program, you hand over your program to what? Relevant compiler. Okay, language compiler. And what language compiler will do after converting or after translating your program? That is what you call source code. Your source code. Now, what will happen? It will generate one special file. Compiler will generate one special file. And this file is called assembly. You call this file as what? Assembly. And what will be the extension of this file? Either it is .exe or it is .dll. Any of these two. Assembly and extension of this will be what? .exe or .dll. Okay. Assembly. And here you can refer. Exe is executable. DLL is dynamic link library. Okay. And one more thing. Connecting with this assembly, remember, assemblies will be of types actually. So that we are not talking in my introduction classes now. So assemblies will be of two types. One is called private assembly. The other is called public assembly. That is also referred as shared assembly. Right. And when you talk about this DLL, DLLs are also of types. DLLs. One is called Win32 DLL. One is called COM DLL. One is called .NET DLL. Types of DLL. So assemblies is one topic we have in my coming classes under C#.NET, and it would be completely a practical orientation. So at that topic, I'll get back to you quite a very detailed discussion on all this stuff. types of assemblies, types of DLLs, all those things we'll study. Right? As of now, I just give you some idea of what we refer as, what we call as what assembly. Okay. And one more thing, this assembly contains a special code, that which you call as CIL code. Obviously, it is in binary format. It means we have one code which is generated by compiler, and that compiler generates a code called CIL code, and that CIL code will be in which format? Binary format. And remember one more thing, CIL code usually will be in two formats. One is binary format, one is text format. Okay, what is CIL code? Yes, this CIL is called Common Intermediate Language. Common Intermediate Language. That is called CIL, Common Intermediate Language, CIL code. And this CIL code, in older versions of .NET, it was actually referred by a name as MSIL code. This was actually called as what? MSIL code. Okay. MSIL code. And one more name also we used to have for it. This was also called as bytecode. Bytecode. And what is MSIL? Same. Microsoft Intermediate Language. Microsoft Intermediate Language, MSIL. Okay. And one more thing. This assembly, which is created by compiler, assembly created by compiler, okay, which is in the form of .exe or .dll, this is also called, this assembly is also called by one more name. What is it? It is referred as PE file. What do you call that? PE file. That is called portable executable. Portable executable, PE file. Okay. And one more thing. And whenever this CIL code is generated by compiler, when you give this code to operating system, when you hand over this code to whom? OS, right? For operating system. Okay, let's talk on that now. So this code, now it is handed over to, yes, different operating systems. Okay. This is one OS. This is one OS. And this is one OS. Okay. Reference to what? CIL code I'm saying. Right. So now code is handed over to what? Different OS. Let me mention them. This is Windows OS. Okay. This one is Windows OS. And this one is Linux OS. Okay. This one is Linux OS. And the third one is, you can refer as lightweight devices. Lightweight device, mobile and what other stuff like. Okay, three things. Okay, so let me call this Windows, Linux, lightweight, devices. Okay. And all these are pointing to what? Operating system. Windows OS and Linux OS, lightweight devices. Okay. And now all these are, I'm pointing to operating system, OS. Okay. And now something important is, whenever we give this CIL code, make this point clear, no OS understands CIL code. Windows cannot understand, Linux cannot understand, no other operating system understands what? CIL code. So best I mention that no OS understands CIL code. No operating system understands what? CIL code. Okay. And another interesting thing here is, whenever we give the CIL code to OS, as I said, no OS understand. For that reason, we have been introduced by one special component now. We are provided by one special component. One second. Here, someone has placed a query. Let me just talk to him. Then I'll get back to you on the content. We are used by one special software component, that which you call as CLR. Okay. CLR. The two, not one CLR. Multiple CLRs they introduce. For Windows, it is Windows CLR. For Linux, they call as mono CLR. What do you call them? Mono CLR. And for lightweight devices, they call as compact CLR. Yes, three types are there. For Windows, we got one CLR. For Linux, we got one CLR. You can say this is one special software component. This is mono CLR. And third one is compact CLR. CLR. Okay, and what is the role of CLR? Okay, let me just describe that as well. CLR is Common Language Runtime. It is CLR. Common Language Runtime. And what about CLR? You got same CLR is being used, not different CLR. Yeah, Windows CLR works only for Windows. Mono CLR works only for Linux. That is the reason you can call CLR is platform dependent. CLR is platform dependent. Okay. Now, what is the role of CLR? Yes, CLR. Next coming class, we have quite a very detailed discussion on the CLR part. So there I'll give you a detailed explanation on it. And what is the role of CLR? CLR makes CIL code understand to operating system. Okay. And what is this OS understandable language? That is what you call machine language. Machine language. That is actually called what? Native code. Native code. Last class I was talking on this concept. Native code. Yes. OS understandable code is called native code. Native code of Linux. Native code of Linux. Native code of lightweight devices. What do you call this as actually? Machine language. Yes. Now it means you have got three types of codes available now for us. Your written code, source code. Compiler generated code, CIL code. CLR generated code, native code. Finally, native code is the code which OS understand. Who will make OS understand that CIL code? CLR. CLR takes responsibility of that. So now let me make you clear that the point is, who is platform independent in this total architecture? So point says CIL code makes .NET application platform independent. Yes. So you can see this architecture and understand that same CIL code we give to Windows CLR. It makes Windows understand about it. Same CIL code you give to Mono CLR. Mono CLR makes Linux understand about it. Same CIL code you give to Compact CLR. Compact CLR makes it understand to lightweight devices. So it means who is making your .NET application platform independent? CIL code makes .NET application platform independent. Okay, this is one part. And another interesting thing that I would like to cover here, especially on a case of this, what do you call, second process, where let's see what is actually happens in the concept of CLR. Because I just gave you, my intention to cover this architecture is to focus on architecture of what? Platform independent. In target was platform independent. Okay, now I'll explain you what is internal happening under CLR. I said now CLR will convert CIL code to native code so that OS understand that code. I said no. So, but how CLR is doing that process? I didn't talk about that. Next second architecture, I'm going to discuss that now. Right. I'll give you the second architecture now. Okay, let's open Notepad. Half of the things are same only, no doubt in that. First, I'll say source code, your written program. That is nothing but C#.NET application. Okay, and that because it is C# related code, obviously you'll have extension of the program as .cs. Just now I said that you give this code to language compiler, and language compiler, as I said, you generates assembly. Yes, generates assembly. Assembly is nothing but what? .exe or .dll file. .exe or .dll file. And remember one thing, language compiler, when generates assembly, that assembly is what you said, .exe or .dll. .exe or .dll. And what do you call this file in another term? PE file. Called what? Portable executable. And remember, assembly contains 4 components in it. Yes. Assembly contains what? 4 components. What are those 4 components? One is called assembly manifest. Yes, one component. Assembly contains what? Assembly manifest. Assembly internal contains one component called assembly manifest. Second, we have called CIL code. In which format? Binary format. Third, something called as metadata. What do you call this as? Metadata. And finally, the 4th component which assembly contains is called resources. So obviously, at this stage, we may not be in a position to understand all this stuff in introduction classes. As I already said you, once again, I repeat, we have one topic to study in my coming classes related to something called assemblies. And there I'm going to explain you in detail about all these things: assembly manifest, CIL code, metadata, and resources. Okay, now This assembly containing all these things, now it is handed over. This assembly is handed over. This all I'm to say. This complete is assembly only, no? Assembly contains all these things, I said. And this is handed over to whom now? It is handed over to CLR, Common Language Runtime. Okay. Let me show you like this one. Language compiler generates assembly. Assembly contains all these things. Assembly manifest, CIL code, metadata. I better call like this now. 1, 2, 3, 4. And I don't put arrow mark here. I better just write in words that contains. Yeah. Metadata, resources, CLR. And here I'll just create some gap for contains. Okay. Now you can read out easily. Assembly contains all these 4, what do you call them? Components. Okay. And now listen. This is handed over to whom? CLR. And what CLR will do now? Yes. Remember, inside CLR, inside CLR, we are provided with around 12 to 14 components are there. Inside CLR. 12 to 14 components are there. Okay. In that 12 to 14 component, there is one component. CLR will hand over no assembly. CLR will hand over what? Assembly. To what? One of the component in CLR. And that component is called JIT compiler. That is called just-in-time compiler. First, I was talking about language compiler. Now I'm talking about JIT compiler. This is at execution, that is at source code translation. Source code translation, JIT compiler for CIL code translation. Okay. And what JIT compiler will do? As the name says, just in time. It means whatever is needed at runtime to run the code, only that part it will translate. Just meaning just in time. At runtime, what is needed for running the code, to execute the code, only that part it will translate. What is not needed, it will ignore that. Okay. So JIT compiler, what is its role? I said no. What is the role of JIT compiler? Translates required code. Okay, I'll mention that point here only. Translates required code in execution. Okay. To whom it will translate? Yes, it will translate required code in execution to what? Native code. And this is for OS. That is what you call machine language. I said it. What do you call this? Machine language. Native code is called machine language. Yes. Okay, one more thing. Listen. And an interesting thing, what you notice, for example, in programming part, there are few things, like one you call as if conditional statement, one we call as looping construct. Programming, I'm saying, under programming. If you go to if conditional statement, you have the code to run once, depending on condition, true or false. Any one will run. If in looping constructs, we have repeated execution of the code. So what JIT compiler will do, it will translate required code in execution to native code. And remember, this native code, whichever has been generated, it will store that code. It will store. Which code I'm saying? Store that code. Native code is stored, better I call. Native code is stored in where? Buffer. or you call cache memory. Yes. Why it will store this code in buffer? Reason is to have reusability. Okay, now I'll explain you easy way to understand. Listen, for example, I have one code as if condition. Okay, I'll write in short. Okay, if condition. Now, under if condition, this is true block, and I have 20 lines of code in it, and I have else block in programming. Again, I have a block, and in this I have some 15 lines of code. 15 lines of code. For example, JIT compiler, when finds that this condition is true, then what JIT compiler will do? Only this 20 lines it will translate to native code, and it will ignore else block. It will ignore else block. It won't translate that remaining 15 lines. The other 15 lines that are there in else block, it won't translate. Acha. Another point I'll say. Another point. This is about if condition process. Okay. For example, instead of if condition, I have while loop now. While I less than or equal to 10. So I want this 20 lines to repeat for 10 times. I want it to run 10 times. This 20 lines of code I want to run for how many times? How many times? 10 times. And what JIT compiler will do now? JIT compiler first time takes all the 20 lines. JIT compiler translates all the 20 lines to native code. All the 20 lines it will translate to native code, and after that, the 20 lines translated native code is that it will store into buffer, so that it should execute the 20 lines for 10 times. I said, please understand, 20 lines 10 times it should run. So first time when we get that, JIT compiler will translate all the 20 lines to native code and stores that code in buffer. And remember, remaining 9 times are there, na? It will go for direct execution. JIT compiler will not do repeated tasks. JIT compiler will not translate the same code again and again. One time it will translate. Remaining 9 times it will directly go for execution. That is the second, that you could say, an architecture related with something called what? CLR. What is the story behind CLR? This is the concept we have for CLR, Common Language Runtime. And today we cover one component that is called JIT compiler. And probably in my next class, I'm going to talk on remaining component. We cannot understand all that stuff in detail in my introduction classes. Few things are fine in introduction classes, few things to be discussed in my practicals. When we start practicals in this, we'll discuss them. Yes, any questions that you want to ask me on this, go ahead, please.
Hello.
Yes, please. Yes, Harish.
This course duration time?
Yeah, it's 4 months. 4 months, Harish. Complete whatever the course content I said, na, that is about the C#, SQL Server, ASP.NET Basics, and ASP.NET MVC Basics, and .NET Core full-fledged it will be. So we planned for this total course for 4 months.
Okay. Class timings?
Actually, I have a batch. Let me make you clear on that. Let me just, because it's a general discussion, so I don't want to disturb my recording. Okay, and now. Yeah. And one more thing. You remember I said just now about JIT compiler? JIT compiler. And remember, as far as .NET is concerned, we have been made available with 3 types of JIT compilers. Let me just mention here so that you can have a reference of what this topic is about. Types of JIT compilers. Okay. One is called the one which I wrote now, no? The one which I wrote, it is called one normal JIT. You call it as normal JIT. Okay. One more is there. That is called pre-JIT. Pre-JIT. And third is called econo-JIT. Yes. 3 types of JIT compilers we have. 3 types. Normal JIT compiler, pre-JIT compiler, econo-JIT compiler. Normal JIT compiler work is the one which I have said there. Translates required code in execution to native code. Translates what? Required code in execution to native code. Yeah. That is normal JIT work. And that native code is even stored where? In buffer. Native code stored in what? Buffer or cache memory. For what? Reusability. What is the role of pre-JIT? What pre-JIT will do? Pre-JIT compiler work is to translate or to compile complete CIL code to native code. Complete. Total CIL code, it will translate to native code. That is whose work? Pre-JIT. And econo-JIT compiler work is to compile required CIL code at execution to native code. The only problem is econo-JIT will not store that code in buffer. Pre-JIT work is what? Translate complete CIL code to native code, not required code. Complete CIL code to native code. What is econo-JIT's work? To translate required code plus that code, whichever has been translated, will not be buffered, will not be cached for reusability. Okay. Now, going forward, the second part that we'll highlight is one is platform independent. That was our first architecture we started with here. Right. These all things I discussed about platform independent only. Now we'll talk about language independent. Language independent. What's the meaning? .NET application logic you can develop in any .NET framework compatible language. Remember one thing, .NET framework is a platform. .NET framework is a platform for .NET application. So remember, we have been provided with 60 plus languages supporting .NET framework. 60 plus languages. So you can develop a .NET logic in any .NET framework compatible language. Not necessary it should be only C#, not necessary it should be only VB, not necessary it should be only VC++. Could be any .NET framework compatible language. And remember, as I said, you know, that we have got around 60 plus languages that are supporting .NET framework now. 60 plus. And in that 60 plus languages, remember one thing, that Microsoft developed languages are only 4. Right? Visual C#.NET, Visual Basic.NET, Visual C++.NET, Visual F#.NET. Microsoft developed languages that are compatible on .NET framework. And whereas we got third-party languages developed by other companies. Even those companies developed languages also run on that .NET framework, platform. In that we have, these are all third-party languages, which I'm listing, you know, Perl.NET, Python.NET, Oberon.Net, APL.NET, COBOL.NET, EFL.NET, Haskell.NET, PHP.NET, JSharp.NET, something called, Pascal.NET, right? These all are what? Third-party languages, third-party. So I'll just give you some idea. So what did I say? Language independent. Microsoft developed languages, how many are there? 4. C#, VB, VC++, F#. Third party. I already gave a very big list now. So 60 plus now. So third party maybe got all this. What are all this? Perl.net, then APL.net, then Cobol.net, then Python.net, then Eiffel.net. Then we have something called Smalltalk.net, then PHP.net, then JSharp.net, and what else we have? Many big list is there. These all are supported, like so .NET Framework compatible languages. What else we have? Oberon.net, then Haskell.net, Haskell, Haskell.net. Right. These all are what? Third-party languages supporting what? .NET Framework. Wherever you want, you can write. If you're familiar with Cobol.net, write your code in Cobol.net. That would run on .NET Framework. Third, we have that is called language interoperability. Yeah, tomorrow's class, I'm going to talk on this. Okay, language interoperability, and we have few more few features. We'll just write for theory, and probably tomorrow we'll complete these features. And if time permits, even I'll start practicals tomorrow. We'll talk on Visual Studio. This tool is there. I'm going to talk on that tool. Visual Studio 2017 we'll be using for our practical session. Visual Studio 2017.